Testing. 1, 2, 3. Is it finally working now? Good. So earlier today, Kokichi said I'm always too loud, that I don't have an indoor voice. But I do. I do. I'm about to prove him wrong. I'll speak so softly, my voice could put him to sleep. Honestly, the dude needs it. He's always texting, sending weird shit to the group chat at 3 in the morning. How does he have the energy to stay up so late? I bet it's the Panta. I swear to the stars above, he's obsessed with it, acting like he'd die without it. Has anyone ever seen him drink water? Not me. But, enough about him. On to the intro. I'm Kaito Momota, a luminary of the stars. Even crying children adore the ultimate astronaut. Welcome, my fellow cadets, to my reading of How to Observe and Understand the Mysteries of the Night Sky. Let's discover what secrets the night sky holds together. Let's begin. Saturn's rings. The planet Saturn is made mostly of gas and liquid. Sound cannot travel on the moon because there is no air. The northern and southern lights fill the sky with color. The constellation of Orion is one of the easiest to spot in the night sky. The Milky Way stretches across the night sky. Looking at the night sky. Wherever you live in the world, you can look up at the night sky and see the moon and the twinkling stars. But how many stars you see depends on the weather and where you are looking from. Skywatch. It is best to look at the night sky away from street and house lights, which block out starlight. You will see the most stars from the countryside, where the sky is darkest. But if you live in a city, you can still see plenty of stars. It can be very cold at night, so bundle up. Remember to bring something to sit on, as well as something to eat and drink. Man, I remember my first time going stargazing. I forgot to bring blankets and even something to sit on. I was so eager, man. Just couldn't wait. Being a young kid, in a field stargazing alone probably wasn't the best idea. I ended up getting lost, but a nice stranger helped me find my way back home. Good times. Which brings me to, don't go out alone at night. Always ask an adult to come with you. When I got home, my folks were understandably not too pleased that I went out alone. But they were nice about it. Thanked the stranger and gave me a stern talking to. Where was I? Oh, right. Night Sky Notebook. Make notes and draw what you see in the sky. Keep a record of the date, the time, and your location. It's always important. The location. The most important. Don't get lost. Okay? Seeing in the dark. Get your eyes used to dark before you look at the night sky. Switch off the house lights, but stay still until you can see where you are going, or you might bump into something. Seeing stars. Once outside, you will need a flashlight to see your notebook. Cover your flashlight with red cellophane, whatever that is. A red light will not spoil your eyesight once you are used to the dark. Red kind of reminds me of Maki. What was I? Oh yeah. Side note. Be careful when using scissors. Cut a piece of red cellophane large enough to cover the end and a little of the side of the flashlight. You will need tape, scissors, and red cellophane. 2. Use the tape to stick the cellophane to the flashlight. A rubber band will also do the job. You can gaze at the stars through your bedroom window. Make sure you turn the lights out first, or you won't be able to see the stars. What's in the night sky? There is more than you think in the night sky. You may recognize the moon and stars, but would you know what a planet, a galaxy, or a star nursery if you saw one? We can see planets, distant galaxies, and much, much more. It is just a matter of knowing what they look like and where to find them. The moon does not always look the same At times, we see only part of it. Some planets have rings around them. Comets visit the Earth's sky from time to time. There are 8 other planets besides Earth. You can see some of them in the night sky. They look like bright, round stars. Most of the objects in the night sky are stars. The sun is our nearest star. It lights up the daytime sky and blots out everything else. The stars, planets, and galaxies are still in the sky. We just can't see them. Just don't stare at the sun, okay? The moon is the closest object to Earth, so we can see it very clearly. Other objects you see in the night sky are a lot bigger than the moon, but because they are so much farther away, they only look like dots of light to us. A nebula is a cloud of gas and dust. Stars are being born in this nebula. Because nebulae are so far away, they look like hazy patches of light in the Earth's sky. Millions of stars live together in galaxies. They too look like these patches of light. Scientists believe the universe began about 15,000 years with a huge explosion called Big Bang. The explosion pushed the young universe apart. Over millions of years, the material formed the galaxies, stars, planets, and finally, the human race. The issue here is radio energy from earthly things, such as car engines and light. Everything in the universe, including you, produces energy. One type of energy is light, another is heat, and another is radio energy. Scientists use special equipment to hear radio energy coming from stars and galaxies. When you change stations on your radio, the hiss you hear between stations is radio energy coming from things on Earth. What is a star? There are billions of stars in the universe. Stars are gigantic balls of glowing gas that live millions and millions of years. There are 2 gases inside a star, hydrogen and helium. A star uses its gases to produce heat and light. The sun is a star, and we feel its heat and light on Earth. In the beginning, stars are born in spinning clouds, made of gas with a little bit of dust mixed in. A force called gravity pulls the gas and dust together, forming small clouds. The spinning clouds then shrink and are formed into ball shapes. Star turns. These spinning balls of gas and dust are stars at the start of their lives. If a ball spins slowly, it will produce one star. If it spins fast, twin stars are born. Medium spin will produce a star with planets. This is what happened when the sun was born. Colors of light. Light is made of different colors. When light shines through water, it splits into these colors. To split the sun's light, you'll need water and a tall glass, a piece of cardboard, and white paper. Cut a long, narrow hole in the cardboard. Place the glass on the paper by a sunny window. Sit the cardboard between the window and the glass. You can now see the colors on the paper. How many colors can you see? Pull and push. Everything in the universe has its own gravity. Gravity is a pulling force that attracts objects toward one another. Inside a star, gravity battles with a pushing force called pressure. As gravity pulls the gas in, pressure pushes it out, so the gas in a star keeps its ball shape. The young stars start to turn their gases into heat and light and slowly begin to move apart. Sisterly stars. The Pleiades, a group of around 300 very young stars. It is also known as the Seven Sisters because the stars are visible to the naked eye. The jeweled box has many bright, colorful stars. You would need a powerful telescope to get this view. They look like a hazy group of stars to the naked eye. Life of a star. Stars live for millions of years. As a star grows older, it changes. The universe contains young, middle-aged, and old stars. biggest stars are 100,000 times bigger than the sun, and the smallest stars are much smaller than Earth. All stars are incredibly hot, but some are hotter than others. Blue-white stars are the hottest of all. Yellow-orange ones, like the sun, are cooler. Red stars are coolest of all, but even red stars are 20 times hotter than a kitchen oven. About half the stars in the universe are double stars. These are two stars that live together, or two stars that look close together because we are looking at them from such a long way away. Use binoculars to look for double stars. Different stars change in different ways. How a star changes depends on how much gas it is made of. When stars such as the sun have used up all their hydrogen, their surface will cool and turn red. They will swell up and become red giants. But don't worry, this won't happen to the sun for another 5,000 million years. Who knows what'll humanity be then? Will we still be around? That's a long time away. Wow. The red giant sun will eventually use up all its fuel. Then it will shrink and become a white dwarf. All the material will pack so close together that the dying sun will be smaller than Earth. Some stars, more massive than the sun, end their lives by blowing themselves apart. Okay, wow. When a star explodes like this, it is called supernova. Beware of the black hole. As some stars die, their material gets more and more squashed together. The star shrinks until it is a point in space. This is called a black hole. The black hole's gravity is so strong that anything that gets too close is sucked into it and can never escape. If you were to get sucked into a black hole, they say you get spaghettified. Yikes. I think that's it for now, cadets. Tune in next time for more. Welcome back, my fellow cadets. Ready for more space facts? 'Cause I sure am. Dots of light. As we look out into space, we see lots of twinkling dots of light. These dots are huge stars, but because they are so far away, they just look like bright specks in a dark sky. It seems as if the Earth is inside a gigantic sphere covered in stars. The dividing line, the equator, an imaginary line around the middle of Earth, divides our world in two. The top half is the northern hemisphere, and the bottom half is the southern hemisphere. The sphere of stars also has an equator dividing it into northern and southern halves. You can see mainly northern stars from the northern hemisphere, and mainly southern stars from the southern hemisphere. If you live near the equator, you can see stars from both halves of the star sphere. Which line are you on? Imaginary lines called latitude lines help us describe where a place is on Earth's surface. They are counted north or south of the equator and are measured in degrees. Knowing which latitude line you live on will help you know which stars are in the sky above your home. Finding directions. To study the stars, you'll need to know in which direction to look. Make a compass with a stick and some stones. 1. Push the stick into the ground. As the sun shines on the stick, it will make a shadow. 2. place their stones at the end of a shadow at different times during the day. The first one in the morning and the last one in the afternoon. The stones will make a curve. The north-south line is where the sun made the shortest shadow. The east-west line cuts at right angles to it. The shortest shadow points north if you live in the northern hemisphere, and south if you live in the southern hemisphere. Twinkling stars. Starlight shines steadily, but stars twinkle in our sky. This is because their light wobbles as it passes through the Earth's atmosphere, the layer of gas that surrounds the Earth. Traveling light. Light travels faster than anything else. The stars are so far away from us that their light takes years to reach Earth. Astronomers, scientists who study the stars and planets, can see very distant galaxies whose light started traveling toward us when dinosaurs lived on Earth millions of years ago. Patterns in the sky. When humans first looked at the sky, they saw hundreds of twinkling dots of light. They connected the dots to make pictures of people, animals, and other things. The pictures helped them, and now us, to remember the stars. Orion, a group of stars, and its picture is called a constellation. This is the constellation of Orion, the hunter. It is one of the easiest constellations to see in the sky. In Greek mythology, Orion was a giant who carried an unbreakable club. Cool as shit, dude. The red star that makes his right bicep is called Betelgeuse. Oh wait, it's Betelgeuse? Yeah, don't confuse with the musical Beetlejuice. Oh, speaking of, did you know Kokichi is a huge fan? Yeah, that's right. And if he says he's not a fan, that's a fucking lie. And I know it. We all know it. You're a fan, Kokichi. So don't you even try to deny it. Wanna know how I know? I caught him listening to the whole soundtrack on Spotify one time while in a study group organized by Kurumi. When he realized I saw, he put on this creepy-ass smile. Ugh, gave me the heebie-jeebies, man. Where was I? Oh, right. Anyway, back to learning. Starlight, star not so bright. Some stars look brighter than others. Over 2,000 years ago, Greek astronomer Hipparchus, let's call him Mr. Hip. Yeah. Mr. Hip numbered the stars 1, 2, 3, 4, 5, or 6. The brightest stars were numbered 1, and the dimmest were number 6. Astronomers still use his numbering system today. This fuzzy patch of light in Orion's sword is the Orion Nebula, a bright heart. The lion is another constellation. The lion's heart is marked by the bright star Regulus. Kinda hard to say. A lion cub cuddles close to the lion, but its scars are not so bright, and it is difficult to see. Make a model of Orion. The stars in a constellation are different distances away from us. If we could see Orion from somewhere else in space, it would have a different pattern. Make a model of Orion using a shoebox, 7 straws, modeling clay, and the picture of Orion on page 18. 1. Measure the straws from the bottom of the page to the 2 stars in Orion's shoulders, the 3 stars in his belt, and the 2 stars on his thigh and ankle. Cut 1 straw for each star. Mold one small ball of modeling clay for each star and stick the ball on to the end of each straw. 2. Cut a window in one end of the shoebox. Turn the box on its side. Arrange the stars inside the box so that when you look through the window, the stars show the pattern of Orion. Stand the straws in small pieces of modeling clay. 3. You can see Orion's pattern through the front window, but from the side, you can see how your stars make a completely different pattern. This is how Orion might look from somewhere else in the Milky Way. Sorry for my stuttering. The Milky River of starlight that stretches across the sky is called the Milky Way. The most visible part of the Great Bear is the 7 stars in the shape of a pan, known as the Plow or the Big Dipper. There are 2 bears in the sky, the Great Bear and the Little Bear. These 2 constellations can be seen all year round. Cepheus, Cassiopeia, and Dragon can also be seen throughout the year. In the course of one night, the constellations change their position in the sky. One star, Polaris, stays still, while the other stars circle around it. At first, you may find it difficult to find these constellations, but it will become easier with practice. Trust me, it will. Heavenly Queen, in an ancient Greek myth, Cassiopeia, Queen of Ethiopia, angered the sea god Poseidon, so he banished her to the sky forever. As Cassiopeia moves around Polaris, she spends some of the time upside down. Sounds kind of fun, actually. Like astronauts in spaceships. Finding Polaris. To find Polaris, ask an adult for the latitude of your home. Face north with the help of your compass. Hold your arm horizontal in front of you and move it the same amount of degrees as your latitude. Your arm will point to Polaris. Brightest star in the night sky is Sirius. It is also called the Dog Star because it belongs to the star constellation called the Great Dog. The Milky Way is very bright in the southern sky because it contains more stars, the part that crosses the northern sky. The cross is made up of 4 stars. It is small, but very bright and easy to spot. It's also on the Australian flag. In the spring, face south to help your compass and find cross. Then swing to the west and you'll see Sirius. Turn to face east and you'll spot Antaurus. I think that's how you pronounce it. The bright star in the Scorpion. The centaur towers over the cross. In Greek mythology, centaurs were wild and violent creatures who were half man, half horse. The centaur in the sky, called Chiron, was not like other centaurs. He taught hunting, medicine, and music. Talk about half horse. Okichi, huh? And the centaur is the brightest cluster of all stars in the sky. Omega Centauri. Near the cross, you will see a beautiful group of stars called the Jewel Box. It contains different colored stars that look like jewels in the sky. The zodiac is a circle of 12 special constellations. The first people on Earth noticed that as the sun, the moon, and the planets moved through the sky, their paths always crossed the same star back. They divided this background into 12 constellations, which we now call the zodiac. The zodiac appears in both hemispheres. The sun moves from one zodiac constellation to another every 4 weeks or so. Animal circle. The word zodiac comes from the Greek word for animal. 11 of the zodiac constellations are animals of sorts. Humans are animals too, FYI. The constellation of the scales was named long after the others. Whenever you look for the moon and the planets, you'll find them in the circle of zodiac constellations. A scorpion is a small and dangerous creature. In Greek mythology, the scorpion stung Orion to death. Don't want to get stung by these fuckers. A curving line of stars marks the scorpion's tail, where it keeps its dangerous stinger. Some star patterns can easily be turned into a picture. In the constellation of the bull, a V shape of stars forms his face and then stretches out to make his horn. Astrologers believe that the positions of the sun, moon, and planets in the zodiac can tell us about the future. Years ago, farmers would ask an astrologer for a weather forecast to know how it would predict the future. Weird. The things people believed back then. Fuzzy objects. In the night sky, stars look like twinkling points of light, and planets look like small, bright disks, but you can also see lots of fuzzy dots and patches of misty light in the sky. These may be galaxies that look misty because they are so far away, or they could be clusters of stars or nebulae that are much closer. The Orion Nebula is a huge cloud of gas and dust where stars are born. The nebula is lit up by the young stars in it. Some of the fuzzy objects we see are not really fuzzy. Clusters of young stars like the Pleiades look fuzzy to your eyes, but you can see they are a group of stars if you use binoculars. But some objects stay fuzzy even when viewed through very powerful telescopes. These fuzzy objects are nebulae. The word nebula, means misty. Look at the sword in the constellation of Orion, and you'll see a misty patch. See page 18. This is the Orion Nebula. You can find Hercules between the constellations of the Lyre and the Northern Crown. The globular think it's globular. Yeah. The globular cluster in Hercules is the brightest in the northern sky. Planetary nebulae. Fuzzy objects such as the Ring Nebula are called planetary nebulae, but they have nothing to do with planets. They are shells of gas blown off by old and dying giant stars. Next up, huge balls of stars. Globular clusters are ball-shaped groups of old stars. They contain hundreds of thousands of stars and look like easy patches of light in our sky. In the northern sky, the constellation of Hercules is a bright globular cluster. God, why is globular such a hard word to say? The brightest globular cluster in the sky is in the constellation of the Centaur in the southern sky. It will look like a hazy patch of light, but you can see some of its stars with binoculars. Over 200 years ago, the French astronomer Charles Messier, I'm just gonna call him CM, started a list of fuzzy objects in the sky. Some of them have names that describe the way they look. Galaxies. Stars live together in gigantic groups called galaxies, which spin and travel through space. Each galaxy holds many millions of stars, and there are millions of galaxies in the universe. Between galaxies, there is only empty space. There are 4 different galaxy shapes: spiral galaxies, barred spiral galaxies, elliptical galaxies, and irregular galaxies. Can't speak today. Speaking of galaxies and empty space, I would appreciate if a certain someone didn't steal my galaxy brownies. Every single time I leave to go to the bathroom, Kokichi steals them. Get your own galaxy brownies, dude. I know it's you, Kokichi, you goddamn thief. And you wonder why no one shares anything with you. That's why all you gotta do is ask. Anyway, back to learning. Birth of a galaxy. A galaxy starts its life as an enormous spinning cloud of gas and dust. The bigger the cloud, the bigger the galaxy. As the cloud spins, stars begin to form, and it starts to change shape. Some galaxies have no particular shape at all. These are called irregular galaxies. They are the rarest type of galaxy. Spiral galaxies are in the shape of a flat disk. The stars form arms that spiral out from a big bulge of stars in the center. All types of stars and nebulae live in spiral galaxies. Fun fact, the Andromeda Galaxy in the northern sky is the most distant object you can see without a telescope. Early astronomers lived in Europe and Asia and could see only the northern sky. Ferdinand Magellan, a Portuguese explorer, sailed south 500 years ago and saw 2 galaxies. They are now called the Small and Large Magellanic Clouds. Some galaxies are round like balls. Others are more like squished balls. Some look as though they have been squished flat. All of these are elliptical galaxies. Barred spirals. In this type of spiral galaxy, the stars form a bar in the center. The arms of stars curl out from both ends of the bar. Okay, cadets. I think we should take a small break. We'll be back shortly to learn more stuff about the best thing ever, space. Welcome back, cadets. Let's learn about the Milky Way. We live in a galaxy called the Milky Way. It is a spiral galaxy with arms swirling out from its center. There are more stars than you could ever count in our galaxy, around 500 million. All the stars that you see in the night sky are in the Milky Way. All types of stars live in the Milky Way, young, old, big, and small. If we could fly above the Milky Way, we would see its spiral shape. But our galaxy is so large that it would take thousands of years to travel to its edge, even in the fastest rockets. Crazy, dude. The more you know. There is a lot of movement in the Milky Way. The stars travel around the galaxy's center, and the whole galaxy spins in space. Although the sun is special to us, it is just another star in the galaxy. The sun lives in one of the spiral arms, about 2/3 of the way out from the galaxy's center. Oh my gosh, did you know? The ancient Greeks thought the Milky Way was milk spilled by the baby Heracles as he drank from the breast of Hera, the queen of the heavens. So dumb. Society's come a long way, I think. Like, wow, I can't believe people actually believed that back then. Can you imagine people still believing this was real? It's honestly weirder than the other thing about the weather predicting the future, to be honest. And if there are people who still believe the spilled milk theory, just know that I, Kaito, luminary of the stars, am disappointed in you. I recommend learning about space and science in general, but especially about space. Speaking of, from the Earth, you can look either into the center of the Milky Way or out to its edge. From out in space, the Milky Way looks like a huge pancake. Yum! A side view shows the bulge at its center where most of the stars live. From Earth, you see a band full of stars stretching across the night sky. Milky Way, sovereign sky. Wherever you live in the world, you can see the path of the Milky Way. It is most spectacular in the sky above the southern half of Earth. Here you can look to the galaxy center, northern sky. You can see the path of the Milky Way with only your eyes. But binoculars will show you that the Milky Light is made of thousands and thousands of stars. Super cool, right? The star we know the best is the sun. Like all other stars in the sky, the sun is an enormous ball of hot, glowing gas. It is the only star we know of out of all the billions and billions of stars to have its own family of planets. Gigantic clouds of hot gas called prominences leap out from the sun. We are nearly 93 million miles, 150 million kilometers away from the sun. That's close enough for us to learn a lot about it. If we were much closer, we would be roasted alive. The sun is the only star we can see in detail. Astronomers use special equipment to study it. By learning about the sun, we learn more about the other stars in the universe. The sun and its family of planets were born from the same cloud of gas and dust. They're so far apart that it would take the fastest passenger plane about 650 years to visit the most distant family member, Pluto. Wait, but Pluto's not a planet. It's a dwarf planet. Not a major one, just to clarify. Moving on, spots often appear on the sun's face. They are areas of cooler, dark gas. Sudden bursts of hot, bright gas are called flares. It is dangerous to look directly at the sun. Its bright lights will damage your eyes, as I've said before, I'm sure. But there is a safe way to see the sun. You will need a pair of binoculars, white paper, thin cardboard, and tape. 1. Place the binocular eyepieces on the cardboard and draw around them. Cut out the 2 circles and push the eyepieces through the holes. Tape to hold in place. Cover one of the big ends of the binoculars with cardboard and secure with tape. Take care when you use scissors. Don't want to get any cuts. Don't want to cut your finger off. Yikes, that'd be gross and painful. Always put safety first, cadets. 2. Position the binoculars so that sunlight shines through them as shown. Move the white paper until you see an image of the sun on it. And when the moon is directly between the sun and the earth, it stops sunlight from reaching a part of Earth. Just as the sun disappears behind the moon, the eclipsed, covered sun looks like a giant diamond ring. The dark spots on the image are sunspots. Drop over the spots daily and keep a record of their movements. Next up, the solar system. The sun and its family is called the solar system. Besides the planets, there are over 60 moons, millions of small rocks called asteroids, billions of comets in the family. It's like going to a family gathering and meeting your extended family. Never been to one, because it's only just me and my grandparents. But anyway, the sun is in the center of the solar system. Everything else travels around it. Can you believe that people actually thought the Earth was the center of the universe? Quite self-centered of humanity, huh? The reality is that the sun is the center of the solar system. Everything else travels around it. There are 9 planets. No. When was this book written? There's 8 planets. Let me see. Let me look that up real quick. First published in 1993 by Dorling Kindersley. Released in hardcover and softcover editions. Some listings specifically noting August 12th, 1993. This one's the one made. This is the one by Carol Stott that I'm reading to you guys. It makes sense. 1993 that this book was made in. Makes a lot of sense. It's a bit outdated, I'll say. But I'm determined to finish it with you guys. I'll correct the things that are not right as we go along. The book says there are 9 planets in the solar system, but there are actually 8 officially recognized planets. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Following the International Astronomical Union's 2006 redefinition, Pluto was reclassified as a dwarf planet, reducing the official count from 9 to 8. And each one follows its own path, called an orbit, around the Sun. All the planets travel in the same direction, but at different speeds from each other. Inner terrestrial planets include Mercury, Venus, Earth, Mars. Those are rocky surfaces. The outer giants are Jupiter, Saturn, that's a gas giant, and Uranus, Neptune, which is an ice giant. And then there's dwarf planets. There are 5 officially recognized dwarf planets, including Pluto, Ceres, or Ceres. I'm not sure how you pronounce that. There's Eris, Haumea. How do you pronounce that? And Make or Makimake? Why are these names so hard to say? Beyond Neptune, while 8 are confirmed, scientists continue to search for potential Planet 9 candidates in the outer solar system. A planet's year is the time it takes to orbit the Sun once. The planets spin as they orbit the Sun. A planet's day is the time it takes to spin around once. There's a fun fact about Pluto, a dwarf planet. Pluto's year is the longest. It lasts 248 Earth years. There is a big difference in size between planets. Jupiter is the largest planet in our solar system, with a diameter about 11 times that of Earth. The smallest planet is Mercury, which is only slightly larger than Earth's moon. Jupiter is a gas giant, while Mercury is a rocky planet closest to the Sun. The ranking of the planets in our solar system is as follows. 1. Jupiter. 2. Saturn. 3. Uranus. 4. Neptune. 5. Earth. 6. Venus. 7. Mars. 8. Mercury. Bring the solar system to your bedroom. To make your bedroom look like the ultimate astronaut's room, all you need is thin cardboard or paper, coloring pencils or pens, a tape measure, and scissors. Step 1. Cut out circles for cardboard or paper for the Sun and the 8 planets. You can use different size round objects, such as plates, bowls, to draw around. Draw the planets on the circles, using the pictures further on in this book as a guide. 2. Position the planets in a line around your bedroom walls. Use the tape to measure their distances from the Sun. Mercury should be 4 inches, 10 centimeters away. Venus 7 inches, 18 centimeters. Earth 10 inches, 25 centimeters. Mars 15 inches, 38 centimeters. Jupiter 4 feet, 6 inches, 1.3 meters. Saturn feet 2.5 meters. Uranus 16 feet, 4.8 meters. Neptune 25 feet, 7.5 meters. Not trying to brag, but I did all of this when I was like 2 or 3 years old. With adult supervision, of course, when using scissors. You should never leave children alone with scissors and knives and stuff. Who knows what they'll do with those? Mercury and Venus, the 2 closest planets to the Sun. Mercury and Venus are both rocky planets, but visitors would find them very different from each other. Mercury is an almost airless world with no atmosphere. It has no layer of gas around it, so you would not be able to breathe. You'd die of suffocation. Venus is surrounded by a very thick layer of clouds. Mercury is scorching hot by day, but without an atmosphere, it cannot hold in its daytime heat, so at night it is unbearably cold. Kinda reminds me of the Gerudo Desert, Legend of Zelda, hot by day and cold by night. Venus shines brightly because the clouds that surround it reflect sunlight well. Venus often looks like a very bright star in Earth's sky, just before sunrise and just after sunset. Really pretty. Because of this, it is known as the morning or evening star. On a side note, Venus's clouds stop us from seeing its rocky surface. Venus is not a very friendly place for humans to visit. If you stepped onto Venus's surface, its hot temperature would bake you. The gas in the clouds would poison you, and the pressure of the gas would be so strong it would crush you. Kinda reminds me of Maki, when she threatens people. Kokichi. The first time I saw her, I just knew that if she were to take on the greatest fighter in Japan, she'd win. But she would never hurt anybody. She's just rough around the edges, so to speak. Anyway, without wind or water, Mercury's craters will never wear away. Mercury is covered with bowl-shaped hollows called craters. Mercury's craters were formed when asteroids crashed into the planet. It is not easy to spot Mercury in the sky because it stays close to the sun. You can sometimes see it near the horizon, where the Earth meets the sky at sunset or sunrise. Making craters. Try making your own crater landscape. You will need a bowl, flour, and objects of different shapes and sizes, such as marble, a stone, or a rubber ball. These objects will be your asteroids. 1. Pour some flour into a bowl, spread it out evenly, and smooth down the surface with a spoon. The flour should be about 2 inches, 5 centimeters deep. This will be your landscape. Place the bowl on some newspaper on the floor. Stand on a stool or chair, and drop your asteroids onto the landscape. Many of the planets and moons have craters. Wear an apron to keep your clothes clean, and use lots of newspaper to avoid making a mess on the floor. I made that mistake when I was 4. Right. 3. See how different sized asteroids make different sized craters. Bigger asteroids make wider and deeper craters. Try throwing the asteroids at 2 speeds. The faster they travel, the more impact they have on the landscape. Planet Earth. There is no other planet like Earth. As far as we know, it is the only planet where there is life. Scientists may say that it's impossible for alien life to exist, but I, Kaito, luminary of the stars, believe we are not the only ones to populate a planet. Who knows, maybe there's a galaxy far, far away that has alien life forms that may or may not look like us. Possible. Make the impossible possible. That's what I always say. Now back to planet Earth. Earth hasn't always looked like it does today, nor will it stay the same. Volcanoes, earthquakes, the weather, and humans all change the Earth in different ways, for better or worse. Mostly for the worse. But I believe humanity will get its act together and change the world for the better someday. A heavy load. In Greek mythology, a giant named Atlas rebelled against the gods. For why though? What did the gods do to make him want to rebel? The gods punished him by making him hold up the Earth's sky forever? How does that make sense? How can you hold up the sky? I swear, Greek mythology just doesn't make sense. Let's just move on to the next. Journey to Earth. Imagine traveling to Earth from far away in space. At first, it would look like a blue planet, but as you traveled closer, you would see white clouds and then brown land and oceans of water. If you were on the moon, the Earth would shine and move across the sky just as the moon does in our sky. The part of Earth you see here is in daylight. It is night for the other side, which is dark. Water covers 3/4 of the Earth's surface. Earth is the only planet that has water. This statement isn't entirely true in this book because Earth is not the only place in the I can't speak today. Solar system with water, but it is the only planet with stable bodies of liquid water on its surface. I think that's what it's supposed to mean. Not that there isn't water that exists on other planets in other forms. Water exists elsewhere as ice or vapor, with vast hidden subsurface oceans found on moons like Europa and Enceladus, that's Saturn, as well as on dwarf planets. The Earth is like a spaceship traveling through space. It is moving at about 66,500 miles per hour. That's 107,000 kilometers per hour. As it orbits the sun, that's more than 100 times faster than a jumbo jet. The sun blasts out particles, tiny pieces, that enter Earth's atmosphere and create amazing light displays. These displays can be seen in the sky toward the North and South poles. They are known as the Northern and Southern Lights. The Earth is made mostly of rock and metal. There were no plants and animals for millions of years. Dinosaurs lived on Earth 200 million years ago. Modern Earth is dominated by humans and their machines. Can you believe that all the land on Earth used to be in one large lump? It gradually split and the pieces moved apart. So long, Pangea. Never got to meet ya. Earth is about 4,600 million years old. In the beginning, the Earth was cold. It warmed up slowly and became so hot, most of its metals and rocks melted. The metals sank to the Earth's center, and the rocks floated on top. As the Earth cooled, steam fell as rain and formed the oceans. The changing moon. The moon orbits the Earth as the Earth orbits the sun. We can see the moon most nights, and often during the day too. But the moon we see seems to change shape in a 29.5-day cycle. The different shapes we see of the moon are called its phases. As the moon orbits the Earth, our view of it changes as the sun lights up more or less the side we see. At times, it seems to disappear altogether, like a certain someone we all know and don't love. You know what you did. Kokichi. The moon's phases. New moon. We cannot see it, as none of the side which faces us is lit up. Crescent. It will soon disappear again. Last quarter. Is on the last quarter of its orbit. Crescent. Wait, no. Gibbous. When the moon gets smaller, it is said to be waning. Full moon. All of the side facing up and facing us, not up, is lit up. Gibbous. 3/4 is visible. The growing moon is said to be waxing. First quarter. It is moved around to the first quarter of its orbit. Now back to crescent. The sun begins to light up our side of the moon. The pull of the Earth's gravity keeps the moon in its orbit. The moon's gravity pulls on the Earth's oceans, causing high and low tides. You can create the phases of the moon yourself. You will need a torch, silver foil, and both a large and a small round object. An apple and a golf ball will do. Cover the golf ball with silver foil. This is your moon. The apple is your Earth, and the torch is your sun. 1. Place the Earth and moon on a table with the sun an arm's length away. 2. Move the moon around the Earth. Stay in the same place while you do this. You'll see that different torchlit parts of the moon, its phases, come in and out of view. Do this project in the dark for a better effect. Trust me, it's better that way. Way cooler too. Way cooler. Everything in the sky moves. The moon follows a path across the sky. If you look at it from time to time one evening, you'll see how its position changes. In this view, right, less than an hour has passed between the top and bottom moons. For reference, this is page 41. The picture is actually pretty cool. The moon in Collosia. You can see surface details on the moon, even in the daytime, and you do not need any special equipment. Because the moon has no atmosphere, there are no moon clouds spoil your view. The dark patches you see are low ones. The brighter areas are highlands. The moon's craters, like Mercury's, were made by space rocks crashing into it thousands of millions of years ago. As long as the weather is clear, you will be able to see the moon regularly and record its changing phases. You can also make drawings of this landscape. Once you have studied the moon with your eyes, look at it through binoculars, see even more detail. There is no air to breathe on the moon, so astronauts have to take air with them. Someday, I'm gonna be wearing that suit, going to space. I hope I can go to the moon someday. That'd be awesome. I mean, awesome. Earth and moon are the only places on which humans have walked. 12 men have been to the moon and returned home safely. Hopefully I'll be 13th. The next time astronauts visit the moon, they will probably set up a base camp where visitors can stay. How cool, dude! Everyday life on the moon would be very different from life on Earth. There would be no noise, because sound cannot travel without air. Also, the moon's gravity is much weaker, so you could jump almost 6 times higher than on Earth. Make a model of the moon. You will need newspaper, 1 cup of flour, a ball, plastic wrap to cover the ball, string, and paint. Make sure to cover the ball with plastic wrap first. 1. Mix the flour with 3 cups of water. Tear the newspaper into small pieces and soak a few pieces at a time in the mixture. Cover half the ball with the wet paper. When completely dry, remove the paper half moon from the ball. Make a second half moon. Cover with 4 layers of paper. 2. Attach one end of the string to the inside of 1 half moon. Put the 2 half moons together and secure with sticky tape. Cover the joint with 3 layers of wet newspaper. Hold the 2 halves tightly together. You can make craters and highlands with more wet paper. 3. When dry, use your own moon sketches or the pictures in this book to paint your moon. Use the string to hang it up. You know what would be pretty fun after the project? Turn it into a disco ball. That'd be pretty fun, wouldn't it? Let's talk about Mars. If you were going to visit a planet, Mars would be the best place to go. It is the next planet from the Sun after the Earth, so it is not too far away. Its surface is the most like ours on Earth, although it is very cold on Mars. There is no air to keep animals and plants alive. Red rocks and dust are everywhere, and even the sky is red. Life on Mars, as recently as 100 years ago, some scientists believed that intelligent life lived on Mars. But we know now that nothing is on this planet. Mars has giant volcanoes on its surface. Long ago, they erupted and helped change the surface of Mars, but today, they are all dead. The biggest volcano is Olympus Mons. It is 3 times bigger than the highest mountain on Earth. Why is Mars called the Red Planet? Because from the Earth, it looks like a red disk. Spacecraft that landed on Mars found that the red color comes with the rusty iron dust. Did you know? A day on Mars lasts nearly 25 hours. A little longer than Earth's day. The Earth lasts 687 days. The red dust covers everything and forms dunes, just like sand dunes on Earth. Martian air is always freezing cold. Also, Mars has ice caps on its north and south poles. If you take a look at page 45, you'll see a Viking photo. This photograph of Mars' barren rocky surface was taken by the American spacecraft Viking 2. Scientists are now planning to send an astronaut to Mars. He or she should be on Mars when you are an adult. Perhaps you will become an astronaut, and it could be you. Or me. Mars has dust storms that can last for weeks. Strong winds pick up the red dust and move it about the surface. With powerful telescopes, we can see the change in the color of Mars as dust moves around. I think this is a good place for a break before we jump into Jupiter. This will be our last break. See you soon, cadets. Welcome back, cadets. Let's dive right into Jupiter. Gigantic Jupiter is made mostly of gas and liquid, with a small rocky core or center. Jupiter has a cloudy outer layer with dark bands and bright zones of different colors. The cloud tops reflect sunlight well, so the planet shines brightly in our sky. Jupiter can be mistaken for a bright silver-white star in the night sky. It moves slowly against the starry background, and you can watch its progress from week to week. It takes about a year to travel through each zodiac constellation. The Earth is tiny compared to Jupiter. It would take 1,330 Earth-sized mouthfuls to fill up Jupiter. Jupiter spins around very fast. This produces high-speed winds and terrific storms. These are much bigger and longer-lasting than storms on Earth. The Great Red Spot Storm has been raging for at least 300 years. Can you imagine living in an area that has a storm for 300 years? I sure as hell couldn't. Jupiter's cloud layer is icy cold, but the planet gets hotter and hotter toward the center. If you look at page 47, you'll see a diagram that kind of looks like a pizza. It says the cloud layer is 800 miles, 1,280 kilometers thick. That's the very top of the diagram, like kind of a crust of a pizza, actually. Yum. And then next is the sea of liquid hydrogen. Below that, the metal hydrogen, and at the very bottom, a rocky metal core. Jupiter's layer of clouds is made mostly of hydrogen gas. Underneath the layer of clouds is a sea of liquid hydrogen. Beneath the sea is more hydrogen, but this time it is in the form of metal. At the center is the planet's rocky metal core. Jupiter has 16 moons. The four biggest, Ganymede, Callisto, Io, and Europa, can be seen from Earth with not. Fun fact, Jupiter has a faint ring that was discovered by spacecraft in 1979. The ring cannot be seen from Earth, even through the most powerful telescopes. We don't know who named planets, but Jupiter is a fitting name for this planet. Jupiter was king of the gods of ancient Rome. The planet Jupiter, being the biggest, is the king of all planets. If you would like to visit Jupiter on your next soul trip, you're out of luck. Jupiter is so far away, it would take a bus around 1,000 years to get there. You'd have to have, like, Miss Frizzle from Magic School Bus to take you there. Too bad the Magic School Bus isn't real. Don't tell Himiko that. She, thinks it's an animated form of biography. There we go. A biography of a real, mage. Next is Saturn. Like Jupiter, Saturn is a giant planet made mainly of gas and liquid. It is surrounded by an amazing system of rings that stretches for thousands of miles into space. Saturn also has the largest family of moons in the solar system. Saturn's material, the stuff it is made of, is not as tightly packed as the other planets. If Saturn could be plain water, it would float. Saturn's clouds are colored by the different materials in them. Scientists have looked through holes in the top layer of gold-colored clouds and seen brown and blue clouds below. The rings can be seen only through a telescope. When astronomers first saw Saturn's rings nearly 400 years ago, they didn't know what they were. Saturn looked as though it had ears. Saturn's rings are not soft, they are made of millions of pieces of rock and ice. Winds, 10 times faster than hurricanes on Earth, whiz around Saturn. Our view of Saturn's rings changes as it orbits the Sun. Every 15 years, Saturn is sideways to us, and the rings seem to disappear. Sometimes we get an excellent view of the rings. Other times, we can see under the underside of the rings. Some of Saturn's rings are made of small pieces that are like icy dust. Others have big car-sized boulders. Some planets are like giant magnets with a magnetic force that stretches into space. Use iron fillings, magnet, thin cardboard, and half a plastic ball to show the magnet around the planet. You should get an adult to cut a plastic ball in half. 1. Place the half ball on the cardboard. Scatter a fine layer of iron filing over the ball. 2. Carefully lift the cardboard and place it over the magnet. Tap the cardboard lightly. The iron filings will form a pattern of lines around the ball. 3. Some planets have lines of magnetic force around them. The lines come from the planet's north and south poles. Uranus and Neptune. These two giant planets are so far away that you need powerful telescopes to see them. We have learned most of what we know about Uranus and Neptune from the space probe Voyager 2. Both planets are made mostly of gas and liquids. Very, very cold. Uranus's ring is made up of 11 separate rings of dark rock. Uranus's outer layers are made mostly of hydrogen and helium gas. Another gas called methane gives the planet its blue-green color. Uranus spins on its side as it orbits the sun. A system of rings and 15 moons orbit around Uranus's middle. Did you know? A summer on Uranus lasts 42 years, but summer on Uranus is very cold. Voyager 2 left Earth in 1977, traveled to the distant giants of the solar system. After visiting Jupiter and Saturn, it reached Uranus in 1986 and Neptune in 1989. Voyager 2 sent thousands of pictures back to Earth. Neptune is made of the same gases as Uranus. It also gets its rich coloring from sunlight shining on the methane gas. Neptune's color is more intense because we can see into its atmosphere. We can also see dark and light spots on its surface. Neptune's rings are very dim, and Neptune is the windiest planet in the solar system. White spots are clouds of methane ice. The Great Dark Spot is a huge storm that is almost as big as planet Earth. Neptune's dark and white spots all travel around the planet at different speeds. Sometimes they are close together, but other times they are apart. One white patch travels so fast that it has a nickname, the Scooter, order of the planets. Make up a sentence using the first letter of each of the planets' names to help you remember their order out from the sun. Start with M for the first planet, Mercury, for example. Most violet, evening, moths chitter slowly until night passes. Or this one, make Voyagers explore many jaw-dropping stars unknown now. Pretty good, right? I totally just made that up right now and did not take 30 minutes to come up with this masterpiece, okay? Pluto, moons, and asteroids. The planet Pluto is so small. Wait. The dwarf planet, though, is so small and so distant from Earth that we cannot get a good look at it. Even with the most powerful telescopes. Pluto has one moon called Charon, which is about half Pluto's size. There are 61 other moons in the solar system, 18 of them living with Saturn. Mercury and Venus are the only planets without any moons. Pluto is more like a moon than a planet. Finally, this book says so. It is really tiny, much smaller than Earth's moon. Pluto is a freezing and dark world of ice and rock. The sun is so far away that Pluto gets hardly any heat and light from it. Charon takes just over 6 days to travel once around Pluto. Pluto was discovered in 1930, but scientists did not discover its moon until 1978. Charon is probably rocky and icy, like Pluto. Spacecraft haven't visited Pluto and Charon yet. Until they do, Pluto and its moon remain worlds of mystery. Some scientists think Pluto was once a moon of Neptune that got knocked out of its orbit. From Pluto, the sun would look like just another bright star. Scientists can tell what the surface of a planet or moon is like by studying sunlight reflecting on its surface. Planets and moons have no light of their own. They are lit by the sun. Using a torch, shine a light on different objects, such as an egg, a ball covered in silver foil, and some coal. See how some objects reflect light better than others. Try this in a darkened room to make it more like space. Moons do not all look the same. Ganymede, one of Jupiter's moons, is icy and covered with craters. Europa is smooth and covered with dark lines. And eruptive Io looks like a giant pizza. Oh my god, it's not just me that thinks that it looks like a giant pizza. Mars has 2 tiny moons, Phobos and Deimos. They are potato-shaped. just like some asteroids. It is possible they were once asteroids that were captured by Mars. There are millions of small rocky bodies called asteroids in the solar system. Most live in between Mars and Jupiter and travel around the sun together. They form an enormous belt around the sun. Oh, they're like travel buddies. Cosmic travel buddies. Comets are enormous balls of snow and dust, like gigantic dirty snowballs. They live together in a huge cloud at the edge of our solar system. Occasionally, a comet is knocked out of the cloud and starts to journey toward the sun. You may see one in the night sky as it passes by Earth. It will look like a fuzzy star. Too bad it won't feel like one, like the Luma plushie I have. The main body of the comet, the nucleus, is in the middle of this big head of gas and dust, called the coma. Why do they name it that? A comet's tail can be millions of miles in length. Some comets travel into the solar system. As a comet approaches the sun's heat starts to turn the comet's dirty snow into gas and dust. A tail grows as the comet loses material. The tail gets smaller and smaller as the comet moves away from the sun. Some comets return again and again to Earth's sky. A comet called Halley's Comet orbits the sun once every 76 years or so. Comets like Halley's don't last forever. They lose material as they travel. When Earth moves through this material, we see a meteor shower in the night sky. The tail always points away from the sun and is longest near the sun. The tail disappears as the comet moves away from the sun's heat. Earth passed through the tail of Halley's Comet in 1910. That's a long time ago. A businessman made money by selling comet pills to people who thought the gas in the tail would poison them. What? That's so crazy. What were even in those pills? Jeez, can you imagine taking pills from someone and not even questioning what's in it? Yikes, imagine the trips they probably had. A light shower. When you see a meteor shower, streaks of light cross the night sky as the comet material burns up in our atmosphere. Meteors are also called shooting stars. Look out for the Geminids shower, which occurs around December 15th to 17th every year. You can see up to 50 shooting stars in an hour. Arizona crater. Car-sized space rocks are too big to burn up in the atmosphere. They crash into Earth's surface. These are called meteorites. The Big Barringer meteorite made this crater in Arizona 25,000 years ago. The crater is more than 3/4 of a mile, 1.3 kilometers wide. Astronomers use special tools to study the stars and planets. The telescope is the most important tool for finding out about the night sky, but astronomers do not look through telescopes very often. Modern telescopes work on their own, recording what they see. That's pretty cool. This information is then passed on to the astronomer, who works in an office. Want to know something else that's cool? The observatory's dome-shaped roof slides open when the telescope is to be used. Imagine the view! So awesome! Telescopes are kept in dome-shaped buildings called observatories. The world's best observatories are placed high on mountaintops. This places the telescopes above the clouds and keeps them away from city lights, which would spoil the view. Especially the Milky Way, which shows up well in the sky above an observatory in Chile, South America. The Magellan space probe orbits Venus. It sends radio messages to Earth, which show what Venus's surface is like. Computers control telescopes, satellites, and space probes, and also help astronomers figure out what they have seen. In modern astronomy, computers are just as important as telescopes. Oh, I wonder if I can get Kibo to, help me observe the sky. Him being a robot and all, he could record what he sees, like a modern telescope. Maybe even better than that. Speaking of robots, we can move on to space robots. On the page, Earth's atmosphere stops some information from space reaching us. To overcome this problem, astronomers send their tools into space. Robots, called space probes, are sent to get a closer look at the planets. Other robots, called satellites, orbit Earth above the atmosphere and look out into space. The Hubble Space Telescope satellite orbits Earth. It looks out into space, seeing farther than any of the Earth-based telescopes. There are observatories on mountaintops all around the world. Special telescopes, called radio telescopes, listen in to the stars. If stars could speak, I wonder what they would talk about. Seeing into a star. Different tools look at the stars in different ways. X-ray satellites take X-ray pictures. A star may not shine very brightly, but an X-ray picture might show that there is a lot of activity in the star and that has lots of energy. Exploring space. We can learn a lot about what is in space by watching from Earth. But traveling into space, we can get a better look and even see things that are invisible from Earth. Astronomers regularly send out satellites and space probes. Astronauts, human space travelers, have also explored space close to Earth. A space probe called Galileo was sent on a mission to Jupiter in 1989. It will take Galileo 6 years to reach Jupiter, even though space probes travel very fast. Once it arrives at Jupiter, Galileo will spend 2 years touring around the giant planet and its moons. The main part of Galileo is about the size of a bus. It has a small probe that it will drop into Jupiter's atmosphere. The umbrella part is used to communicate with Earth. Astronomers use their computers to talk to the computers on space probes. Space probe computers send back what the probe has found out. Back on Earth, big dishes work like enormous ears, collecting the radio messages from the probes. Jupiter's magnetic force will be measured by its long arm. Galileo's long arm, I mean. Jupiter doesn't have arms. It's a planet. When astronauts are outside their spacecraft, they must be careful not to fly off into space. Sometimes they wear backpacks that contain small rockets, allowing the astronauts to control their movements. Everything is almost weightless in space. Things have to be tied down in case they float away. Drinks are sucked through straws, and if any drink escapes, it forms into small balls, which float like little balloons. Rockets and small planes, called space shuttles, carry satellites, space probes, and astronauts into space. Use a balloon to see how a rocket space shuttle blasts off from Earth. 1. Blow up the balloon, but don't tie the end. Hold it between your fingers instead. 2. Let the balloon go. The air rushing out of the balloon makes it move forward. When a rocket or a shuttle is launched, a stream of hot gases spurts out of its tail down toward Earth. The rocket is pushed upward and blasts off into space, just like the balloon blasting away from you. And that's the end of the book. That was a lot of fun. I don't remember why I was recording at all. It'll come to me later, I guess. What's important is I had fun. I hope you did as well, my fellow cadets. Kaito Momota, Luminary of the Stars, signing off.